I'd like to solve this equation that has a square root in it. First thing I'm going to do is isolate the square root, get it by itself on its side of the equation. In order to do that, I'm going to add this 9, both sides of my equal sign. So now I have the square root just by itself. And on the right I have x now plus 9. I have variables underneath the square root, and I'd like to not have that. I'd like to get them out. In order to do that, I'm going to need to square both sides of my equation. So I'm going to square on the left, and I'm going to square on the right. Notice I'm squaring both sides, the entire left-hand side, the entire right-hand side, not each term, each side. When I square something that's under a square root, the squared and the square root are inverse operations. They undo each other, so I'm left just with this 2x plus 26, the thing that was underneath the square root, equals x plus 9 squared. If you can do that in your head, that's wonderful. If you can sometimes do it in your head, come off to the side here and go, okay, that means x plus 9 times itself. And I'm going to get x squared plus 9x. When I distribute the 9, I get another 9x, and 9 times 9 is 81. I'll combine my like terms to get x squared plus 18x plus 81. Now the square root's gone. That's good news. And what I have is a quadratic equation. It has an x squared in it. So we have 3 choices how to solve these. There's a fourth one, but we don't talk about that one. So I could use square roots. Well, that doesn't sound like a good choice here because I have this x term. I think it's going to be hard to use square roots. We can solve by factoring, or we can use the quadratic formula. Well, either factoring or the quadratic formula is going to require me to put all my terms on one side with 0 on the other, so I'm going to go ahead and move this 2x plus 26 by subtracting it over with the rest of the terms. So now I have 0 on the left, x squared, and now I have plus 16x, and that's 55. Well, let's see. Factoring, those are pretty big numbers to use the quadratic formula. I know it'll work, but I'd rather factor if I can, because sometimes it's faster. So 55, there aren't that many ways to multiply and get 55. 11 times 5 is one that springs to mind, and that's actually going to do the job. So 55 is 11 times 5. 11 plus 5 is 16. And we're there, everything's positive. So x plus 5 times x plus 11. Next, I'm going to solve this quadratic equation by setting each factor equal to 0. And I have 2 little tiny linear equations, which I can solve by subtracting. And if you can make the jump from x plus 5 equals 0 to x equals negative 5 without writing down anything in between, that's fine at this stage in the game. And if you need to write it down, write it down. That's fine too. So I have 2 potential solutions to my equation. They might or might not be actual solutions, because when I multiply by the variable, like I did right here, when I squared everything, sometimes we introduce extraneous solutions that certainly look like solutions, but that don't actually work in the original equation. So we got to try them. I'm going to do one at a time. I'm going to start with x equals negative 5. Here we go. 2 times negative 5 plus 26 minus 9, and I want to know, does that equal negative 5? Well, let's see. That's negative 10 plus 26. That's the square root of 16 minus 9. Square root of 16 is 4. 4 minus 9 does in fact equal negative 5. So that one works. It's a keeper. X does equal negative 5. Let's try the other one, see what happens. The square root of 2 times negative 11 plus 26 minus 9, and I wanted to, does that equal x? X is negative 11. So let's see. That's negative 22 plus 26. Negative 22 plus 26 is positive 4. The square root of 4 is 2. 2 minus 9 is not, in fact, negative 11. 2 minus 9 is negative 7. So that one does not work. Negative 11 is an extraneous solution, and I have to throw it out. I have one solution to this equation. X equals negative 5.